So today I will discuss applications of Fermat's theorem. So basically আজকে আমি Fermat's theorem problem গুলো discuss করব, ঠিক আছে? So first note this statement. What is Fermat's theorem? So note this statement. This statement. Let A be an integer. Okay. If P is prime and P does not divides A, then A to the power P minus 1, then A to the power P minus 1. So this is congruent to 1 modulo P. So first of all, note this statement. Fermat's theorem states that let A be an integer if P is prime and P does not divides A. If P is prime and P does not divides A, then A to the power P minus 1. So this is congruent to 1 modulo P. A to the power P minus 1. So this is congruent to 1 modulo P. Okay. Or this can be written as A to the power P. So this is congruent to A modulo A to the power P minus 1 is congruent to 1 modulo P. This can be also written in the form that A to the power A they just simply multiply, right? So A to the power P is congruent to A modulo P. ठीक है? So note this statement. Let A be an integer and if P is prime and P does not divide, say P A के divide करबे ना, then A to the power P minus 1. So this is congruent to 1 modulo P. Then A to the power P minus 1. So this is congruent to 1 modulo P. Or this can be also written in the form A to the power P. So this is congruent to A modulo P. Right? Okay. Then let A be an integer if P is prime and P does not divide A, then A to the power P minus 1. So this is congruent to 1 modulo P, or A to the power P is congruent to A modulo P. Okay. So let us consider an example. So note this problem. Note this problem. If P is prime greater than 2, P is prime greater than 2. Therefore, only 2 is the even prime. Right? All prime numbers are odd. Right? If P is prime greater than P2, what does it mean? That means P is odd prime. Right? P is prime greater than 2. That means P is odd prime. That is the value of P will be 3, 5, 7 like this. Right? Prime number গুলো কি হবে? 2, 3, 5, 7. তাই তো? Dot dot. ঠিক? P greater than 2. P greater than 2. That means P starts from 3. 3, 5, 7, 11, 13. Right? P greater than 2. That means P is an odd prime. Okay. P is an odd prime. দেখো একমাত্র 2 is the only even prime. All primes are odd, right? So if P is prime greater than 2, then show that 1 to the power P plus 2 to the power P plus 3 to the power P dot dot P minus 1 to the power P. So this is congruent to 0 modulo P. ঠিক আছে? Or similar problem, if P is odd prime, then show that 1 to the power P plus 2 to the power P plus 3 to the power P plus dot dot P minus 1 to the power P. So this is congruent to 0 modulo P. So note this example. If P is prime greater than 2, then show that 1 to the power P plus 2 to the power P plus dot dot P minus 1 to the power P. So this is congruent to 0 modulo P. Similar problem, if P is odd prime, then show that 1 to the power P plus 2 to the power P plus 3 to the power P dot dot P minus 1 to the power P. So this is congruent to 0 modulo P. Okay. ঠিক আছে? So answer. Just recall Fermat's theorem. Okay. Just recall Fermat's theorem. Fermat's theorem states that let A be an integer if P is prime and P does not divides A, then A to the power P. So this is congruent to A modulo P. A to the power P is congruent to A modulo P. where a is an integer, right? So by Fermat's theorem, we get by Fermat's theorem. So what we can write? By Fermat's theorem, we get a to the power p. This is congruent to a modulo p for any integer, a. ঠিক আছে? Now if we put a is equal to 1, so 1 to the power p, so this is congruent to 1 modulo p. If you put a is equal to 2 to the power p, so this is congruent to 2 modulo p, right? Dot dot, okay, dot a to the power, just if we replace p, a is equal to p minus 1, so p minus 1 to the power p minus 1, so this is congruent to p minus 1 modulo p. Okay, so what we get? We get 1 to the power p, so this is congruent to 1 modulo p. 2 to the power p, so this is congruent to 2 modulo p. 3 to the power p, this is congruent to 3 modulo p. Dot p minus 1 to the power p, so this is congruent to p minus 1 modulo p, right? Now adding all these congruence, যখন তুমি অ্যাড করবে তাহলে কি হবে? লেফট হ্যান্ড সাইডের টার্মগুলো অ্যাড, so this is congruent to 1 plus 2 plus dot p minus 1 modulo p. ঠিক আছে? So adding all the congruence, we get adding all the congruence, we get 1 to the power p plus 2 to the power p plus dot 1 to the power p plus 2 to the power p plus dot plus p minus 1 to the power p minus 1. So this is congruent to কি হবে? 1 plus 2 plus 3 dot p minus 1. 1 plus 2 plus dot p minus 1, right? Okay, ঠিক আছে, মডিউলো p, ঠিক আছে, right? Just see, suppose a is congruent to b modulo m, ঠিক, c is congruent to d modulo m, then a plus c, so this is congruent to কি হবে? b plus d modulo m. Just apply this property. If a is congruent to b modulo m, c is congruent to d modulo m, if we add, so what we get? a plus c is congruent to b plus d modulo m. ঠিক আছে, just a property apply করো, ঠিক আছে? Okay, now just see 1 plus 2 plus 3 dot n, 1 plus 2 plus 3 dot n, let's see, 1 plus 2 plus 3 plus dot n, so this will be n into n plus 1 divided by 2. We know this result, n into n plus 1 divided by 2. So this is congruent to 1 plus 2 plus dot p minus 1. So n into n plus 1, n into n plus 1 divided by 2. So this is, okay, 1 plus 2 plus dot p minus 1. So ultimately what we get? P plus 1 minus 1 cancel, so ultimately we get p into p minus 1 divided by 2 modulo p, right? Okay. Now, what is given? P is odd prime, right? P greater than 2, that means P is odd prime. So P minus 1, that is even number, hai ki na? P is odd prime, that means P cannot be 2. P 2 होते पारे ना, ठीक? ताहले P value की होते पारे? 3, 5, 7 like this, okay? So P minus 1, that must be even, hai ki na? P is odd, right? So P minus 1, that is even. আমরা জানি যে even number is always divisible by 2. Even number is always divisible by 2. So this must be divisible by 2. ঠিক? Remainder কি হবে? 0. So this is congruent to 0 modulo p. Okay? P into p minus 1. P minus 1, that is an even integer. So every even integer is divisible by 2. ठीक? So p minus p into p minus 1, that must be divisible by 2. ठीक? So what we get? That is remainder is 0. So this is congruent to 0 modulo p, since p minus 1, this is even, p is odd, so p minus 1, that is even. So we proved that. So we proved that 1 to the power p plus 2 to the power p plus dotted p minus 1, sorry, p minus 1 to the power p. Please correction this, p minus 1 to the power p. Sorry, this is just you replace a by p minus 1. Sorry, please correction this, p minus 1 to the power p. P minus 1 to the power p. Okay, p minus 1 to the power p. Sorry, p minus, just you replace a by p minus 1. So p minus 1 to the power p. So this is congruent to p minus 1 modulo p. Okay, ঠিক আছে? So we prove this. ঠিক আছে? একদম ইজি, ঠিক আছে? জাস্ট ফার্মার্স থিওরেমে জাস্ট আমি কি করেছি, এর ভ্যালু 1, এর ভ্যালু 2, এর ভ্যালু 3 ডট এর ভ্যালু আমি কি পুট করেছি p minus 1, we and then adding all these congruence we get this. ঠিক আছে? ঠিক আছে? Okay. So let us consider next example. So note this problem. If p is odd prime, that means p is greater than 2, p is odd prime, then show that 1 to the power p minus 1 plus 2 to the power p minus 1 plus 3 to the power p minus 1 dotted p minus 1 to the power p minus 1. So this is congruent to minus 1 modulo p. Okay. So first of all, note this problem. If p is odd prime, then show that 1 to the power p minus 1 plus 2 to the power p minus 1 dotted p minus 1 to the power p minus 1. So this is congruent to 1. This is congruent to 1 modulo minus 1 modulo p. Just apply Fermat's theorem. Fermat's theorem states that a to the power p minus 1. So this is congruent to 1 modulo p, right? ঠিক আছে? So by Fermat's theorem we have, by Fermat's theorem we have a to the power p minus 1. So this is congruent to 1 modulo p. ঠিক আছে? Okay. Now just you put a is equal to 1. Next you put a is equal to 2. Next you put a is equal to p minus 1. So 1 to the power p minus 1. So this is congruent to 1 modulo p. 2 to the power p minus 1. So just you put a is equal to 2. So 2 to the power p minus 1. So this is congruent to 1 modulo p dot dot. p minus 1, just you put a is equal to p minus 1, so p minus 1 to the power p minus 1, so this is congruent to 1 modulo p. তাহলে এখানে টোটাল কতগুলো রিলেশন আছে, টোটাল ইকুয়েশন আছে p minus 1, right? We have p minus 1 congruence, ঠিক আছে? Now just adding, so adding all this congruence, adding all the congruence we get, so adding all the congruence we get 1 to the power p minus 1, the left hand side add, so this is congruent to 1 plus 1 plus 1 modulo p, ঠিক আছে? So 1 to the power p minus 1 plus 2 to the power p minus 1 plus dot dot plus p minus 1 to the power p minus 1, so this is congruent to 1 plus 1 plus dot dot 1 modulo, ওকে? তো এখানে কতগুলো 1 পাবে, দেখো টোটাল ইকুয়েশন হচ্ছে p minus 1, so if we add, so what we get, p minus 1, right? 1 plus 1 plus 1, so this is congruent to p minus 1 modulo p, ঠিক আছে? কত টাইমস 1 আছে এখানে, p minus 1 টাইমস, ঠিক আছে? কত টাইমস 1, p minus 1, so if we add, so what we get, p minus 1. Now note this point, note p minus k, this is congruent to minus k modulo p, p minus k, so this is congruent to minus k modulo p, so note this point, p minus k, so this is congruent to minus k modulo p, p minus 1, p minus 1, so this is congruent to minus 1, right? This is congruent to minus 1 modulo p. It is very important, note p minus k, so this is congruent to minus k modulo p, so p minus 1, so this is congruent to minus 1 modulo p, ঠিক আছে? Okay, right? So next example, so note this problem, show that a to the power 12 minus b to the power 12 is divisible by 91 if a and b are prime to 91, okay, ঠিক আছে? So note this problem, so note this problem, so that a to the power 12 minus b to the power 12 is divisible by 91 if a and b are prime to 91, okay, if a and b are prime to 91, ঠিক আছে? So note this, so that a to the power 12 minus b to the power 12, so this is divisible by 91 if a and b are prime to 91. দেখো, first of all note this result, suppose, so note this point first, note suppose a is congruent to b modulo m, let a is congruent to b modulo m and a is congruent to b modulo n, then a is congruent to b modulo mn, okay, provided m and n are relatively prime, that is GCD of M and N is 1. So first of all, note this: if A is congruent to B modulo M and A is congruent to B modulo N, then A is congruent to B modulo ki hobe Mn, provided M and N are relatively prime, that is co-prime. Co-prime means GCD of M and N is 1. So if GCD of M and N is 1, that is M and N are relatively prime, then we conclude that A is congruent to B modulo Mn. ঠিক আছে? Okay, right? So now here we have to show that what is our target. Here we have to show that A to the power 12 minus B to the power 12. So this is divisible by 91. This is divisible by 91. That means we have to show that A to the power 12 minus B to the power 12. So this is congruent to 0 modulo 91. So this is our target basically. This is our target. A to the power 12 minus B to the power 12. So this is congruent to 0 modulo 91. That means A to the power 12 minus B to the power 12. This is divisible by 91. ठीक है, रिमाइंडर की होता है 0 होता है, right? Okay, so we have to show that 91 divides A to the power 12 minus B to the power 12. That means we have to show that A to the power 12 minus B to the power 12. So this is congruent to 0 modulo 91. ठीक है, remainder 0, right? ठीक है, okay. Now 91, देखो 91 के प्राइम फैक्टराइजेशन करो. 91 is equal to 13 into 7. 13 into 7, that is 91. ठीक, here it is given that A is prime to 91, right? So here 91, that is 7 into 13, that is 13 into 7. It is given that A is prime to 91. That means A and 91 that are relatively prime. So A is prime to 91. That means A is prime to 13 as well as A is prime to 7. ठीक है? Since it is given that since A is prime to prime to 91, so A is prime to 13 and as well as A is prime to 7. ठीक, I repeat, A is prime to 91. What does it mean? That means A is prime to 13 as well as A is prime to 31. So A is prime to 13 and 7. Okay, A is prime to both 13 and 7. ठीक है? Now just apply Fermat's theorem. Fermat's theorem states that let A be an integer and P does not divides A. Right? Then A to the power P minus 1. So this is congruent to A to the power P minus 1. So this is congruent to 1 modulo P. Right? ठीक है? Okay. This is Fermat's theorem. If P is prime and P does not divides A, then A to the power P minus 1, this is congruent to 1 modulo P. So by Fermat's theorem, we have by Fermat's theorem, what we can write? A to the power P minus 1, P is 13. A to the power P minus 13 minus 1, that is 12. So A to the power 12. So this is congruent to 1 modulo P. P is 13. a to the power p minus 1, so this is congruent to 1 modulo p is 13, so 13 minus 1, that is 12, so a to the power 12, so this is congruent to 1 modulo 13, and a is prime to 7, so 7 is prime, so a to the power p minus 1, that is a to the power 6, so this is congruent to 1 modulo p, that is 1 modulo 7. We can write this, ঠিক আছে, okay, right? So what we get a to the power 12, so this is congruent to 1 modulo 13, and a to the power 6, so this is congruent to 1 modulo 7, ঠিক আছে. Now a to the power 6, that is from second congruence. Now a to the power 6, so this is congruent to 1 modulo 7, so this implies, just square karo, so a to the power 12, so this is congruent to 1 square, that is 1 modulo 7. Suppose a is congruent to b modulo, suppose p, then a to the power m, so this is congruent to b to the power m modulo p. Okay, just apply this result. If a is congruent to b modulo m, then a to the power m, so this is congruent to b to the power m modulo. If suppose a is congruent to b modulo p, then a to the power m is congruent to b to the power m modulo p. So I'm just square korichi, so a to the power 6 square, so this is congruent to 1 square modulo p, ঠিক আছে. So this implies a to the power 12 minus 1, so this is congruent to 0 modulo 7, ঠিক আছে. Okay, so now we have, just see first a to the power 12 from this relation, a to the power 12 is congruent to 1 modulo 13. So now from this, what we can write, a to the power 12 minus 1, so this is congruent to 0 modulo 13. So now, so what do we get? We see that now we have a to the power 12 minus 1, a to the power 12 minus 1, so this is congruent to 0 modulo 13, and also we have a to the power 12 minus 1, so this is congruent to 0 modulo 7, ঠিক আছে. Okay, right? So from this, what we can write, just apply this result. Suppose a is congruent to b modulo m and a is congruent to b modulo n, then a is congruent to b modulo mn. Modulo ki hobe? Mn hobe, provided m and n are relatively prime, that is GCD of m and n is 1. Here we see that a to the power a is congruent to b modulo m and a is congruent to c modulo n, ঠিক আছে. Just apply this. A is congruent to b modulo m, a is congruent to b modulo n, then a is congruent to b modulo mn. কন্ডিশনটা কি? m and n কি হতে হবে? রিলেটিভলি প্রাইম হতে হবে. দেখো এখানে 13 এবং 7, 13 and 7, they are relatively prime. GCD of 13 and 7 is 1, right? So 13 and 7 are relatively prime. So from these two, what we can write? So this implies a to the power 12 minus 1, so this is congruent to 0 modulo 13 into 7, that is 91. Is it clear? A is congruent to b modulo m and a is congruent to b modulo n, then a is congruent to b modulo ki hobe? Mn hobe, provided GCD of mn is 1, that is m and n are relatively prime. So here we see that 13 and 7, so these are relatively prime. So we can write, so a to the power 12 minus 1, so this is congruent to 0 modulo 91. Why? Since GCD of 13 and 7 is 1, ঠিক আছে। Similarly we can prove that we can show that a to the b to the power 12 minus 1, so this is congruent to 0 modulo 91, ঠিক আছে, একদম সেম ভাবে জাস্ট ইফ ইউ রিপ্লেস a by b you get this. নাও এতে সাবট্রাক্ট করো, দেখো সাপোজ a is congruent to b modulo m and c is congruent to d modulo m. So then a minus c, so this is congruent to b minus d modulo m. Just subtract. তাহলে কি লিখতে পারি, this minus this is congruent to 0 modulo 91, ঠিক আছে, okay. So thus what we can write, thus this minus this, a to the power 12 minus 1 minus b to the power 12 minus 1, that means a to the power 12 minus b to the power 12, দেখো তুমি সাবট্রাক্ট যখন করছো minus 1 plus 1 ক্যান্সেল হয়ে যাবে, so a to the power 12 minus b to the power 12, so this is congruent to 0 modulo 91, দেখো বিয়োগ করো this minus this, so minus 1 minus plus 1 cancel, so a to the power 12 minus b to the power 12, so this is congruent to 0 modulo 91, right? That means a to the power 12 minus b to the power 12, so this is divisible by 91, right? So hence we conclude that 91 divides a to the power 12 minus b to the power 12, okay, ঠিক আছে. So we prove that a to the power 12 minus b to the power 12, so this is divisible by 91, okay, ঠিক আছে, right? সাইড নোট গুলো অবশ্যই করবে, তাহলে তোমরা প্রপার্টিজ গুলো, কোন কোন প্রপার্টিজ গুলো আমি অ্যাপ্লাই করছি সেই প্রপার্টিজ কনসেপ্ট গুলো তোমাদের ক্লিয়ার হবে, ঠিক আছে. সো বেসিক্যালি দ্যাট ওয়াজ আওয়ার টার্গেট, 91 divides a to the power 12 minus b to the power 12, that is a to the power 12 minus b to the power 12, so this is congruent to 0 modulo 91, so we prove this, ঠিক আছে, okay. So let us consider next example. So note this problem, same problem, example 3, example 4 are similar problems. Show that a to the power 18 minus b to the power 18, so this is divisible by 133 if a and b are co-prime with 133, that means a is prime to 133, also b is prime to 133, right? It is given that a is prime to, it is given that a is prime to 133, that means GCD of a and 113 is 1. b is co-prime with 133, that is GCD of b and 133 is 1, okay. So problem টা এইভাবে দিতে পারে, if GCD of a and 133 is 1, GCD of b and 133 is 1, then prove that a to the power 18 minus b to the power 18, so this is divisible by 133. So these two problems are similar, okay. Example 3, example 4, same problem, right? So first তুমি কি করবে, 133 কে প্রাইম ফ্যাক্টরাইজেশন করো, ঠিক আছে, that is 130, that is 7 into 19, okay, ঠিক আছে. So here, so first of all note this problem, so that a to the power 18 minus b to the power 18 is divisible by 133 if a and b are co-prime with 133. Similar problem, if GCD of a and 133 is 1, that means a and 133, GCD of a and 133 is 1, GCD of b and 133 is 1. দেখো GCD of ab এটাকে কিন্তু আমরা সিম্পলি ফার্স্ট ব্র্যাকেটও রিপ্রেজেন্ট করতে পারি, ফার্স্ট ব্র্যাকেট ab, that means GCD of a and b, okay, ঠিক আছে. This is another GCD of a and b is 1, this can be also written in the form just simply within bracket a comma b is 1. That means বুঝতে হবে তোমাকে a and b are relatively prime. Okay, ঠিক আছে? Okay, so answer. First আমি কি করব, 133 কে prime factorization করব, that is 7 into 19. So here 133, that is 7 into 19. ঠিক আছে? Now a is co-prime with 133. That means a is prime to 133. Since a is prime to 133, so a is prime to 7 as well as a is prime to 90. ঠিক আছে? Okay, since a is prime to since a is prime to 133, so a is prime to both 7 and 19. Okay, ঠিক আছে? Okay, now by Fermat's theorem, what we can write, a is prime to 7 as well as a is prime to 9, is 7 prime. ঠিক? So by Fermat's theorem, Fermat's theorem states that a to the if p is prime, then a to the power p minus 1, so this is congruent to 1 modulo p. P is 7, so a to the power p minus 1, that means a to the power 6, so this is congruent to 1 modulo 7. And p is 19, a to the power p minus 1, that is a to the power 18, so this is congruent to 1 modulo 19. P is 19, so a to the power p minus 1, so this is congruent to 1 modulo p, 1 modulo. ঠিক আছে? এবার এই রিলেশন a to the power 6 দেখো আমাকে আনতে হবে a to the power 18. So now a to the power 6, now a to the power 6 is congruent to 1 modulo 7, so this implies a to the power, দেখো স্কোরিং করো, that is a to the power 18, so this is congruent to 1 modulo 7, so this implies a to the power 18 minus 1, so this is congruent to 0 modulo 7. ঠিক আছে? Also a to the power 18 is congruent to 1 modulo 19, that means a to the power 18 minus 1 is congruent to 0 modulo 19. ঠিক আছে? Now what we get, so we have basically two relations. A to the power 18 is congruent to 0 modulo 19, and a to the power 18 minus 1, so this is congruent to 0 modulo 7. ঠিক আছে? So what do we get? So we get a to the power 18 minus 1, so this is congruent to 0 modulo 19, and a to the power 18 and a to the power 18 minus 1, so this is congruent to 0 modulo 7. Now just apply this property. If a is congruent to b modulo m and a is congruent to b modulo n, if m and n are relatively prime, then a is congruent to b modulo mn, right? Okay, so here 9 and 7, that is relatively prime, that is GCD of 19 and 7 is 1, so we can write this is congruent to a to the power 18 is congruent to 0 modulo কি হবে 19 into 7, right? ঠিক আছে, so this implies a to the power 18 minus 1, so this is congruent to 0 modulo 19 into 7, 19 into 7, that is 133, right here, since GCD of 19 and 7 is, ঠিক আছে? So what we proved? We proved that a to the power 18 minus 1, so this is congruent to 0 modulo 133. Similarly, we can prove that b to the power 18 minus 1, so this is congruent to 0 modulo 133. এবার যদি subtract করো, so if we subtract, so what we get? This minus this, that is a to the power 18 minus b to the power 18 হয়ে যাবে, minus 1 plus 1 cancel হয়ে যাবে. So therefore, thus a to the power 18 minus b to the power 18, so this is congruent to 0 modulo 133. That means a to the power 18 minus b to the power 18, so this is divisible by 133. So hence 133 divides a to the power 18 minus b to the power 18, that is a to the power 18, that is a to the power 18 minus b to the power 18, so this is divisible by 133. Okay, ঠিক আছে? Similar problem, this is your assignment, same problem. So note this problem, show that a to the power 16 minus b to the power 16 is divisible by 85. First আমি কি করব, তাহলে 85 কে প্রাইম ফ্যাক্টরাইজেশন করব. So 85, that is 17 into 5, right? Okay, so note this problem, show that a to the power 16 minus b to the power 16, so this is divisible by 85 if a and b are co-prime with 85, that is a is prime to 85, b is co-prime with 85, that means GCD of a and 85 is 1, GCD of b and 85 is 1. Okay, so note this problem, show that a to the power 16 minus b to the power 16, so this is divisible by 85 if a and b are co-prime with 85. So first আমরা কি করব, 85 কে প্রাইম ফ্যাক্টরাইজেশন, রাইট? 85 কে আমি কি করব, প্রাইম ফ্যাক্টরাইজেশন করব, ঠিক আছে? দ্যাট ইজ 85 is 17 into 5, ঠিক? So since a is prime to 85, so a is prime to 17, so a is prime to 5. Now apply Fermat's theorem, so a to the power p minus 1, that is a to the power 17 minus 1, that means a to the power 16 is congruent to 0 modulo 17, as well as a to the power p minus 1, that is p is 5, so a to the power 4 is congruent to 1 modulo 5. Okay, same bhabe tomra ei problem ta solve korbe, this is your assignment. Okay, so note this problem, show that a to the power 16 minus b to the power 16 is divisible by 85 if a and b are co-prime with 85. Okay, ঠিক আছে? This is your assignment. So next problem, note this problem, if p and q are distinct primes, and a be an integer not divisible by both p and q, a is an integer not divisible by p and q. Okay, that is a is not divisible by p, as well as a is not divisible by q. Okay, we have to show that a to the power p minus 1 into q minus 1, so this is congruent to 1 modulo pq. p and q are distinct primes. Suppose p is 2, q is 3, so obviously দেখো দুটো প্রাইমলি ডিস্টিংক্ট, এদের জিসিডি কি হবে, GCD of 2 and 3 is always 1. So here P and Q are distinct primes. That means GCD of P and Q is 1. Okay. So first of all, note this problem. If two primes are distinct, if P and Q are distinct prime, that means GCD of P and Q must be 1. That means P and Q are relatively prime. Okay. Duto prime number always co-prime. Okay. Suppose if we consider P is equal to 5, Q is equal to 7, 5 and 7 GCD Q have 1 have. So here it is given that P and Q are distinct primes. That means GCD of P and Q is 1. Okay. So note this problem. If P and Q are distinct primes and A be an integer not divisible by both P and Q, then show that A to the power P minus 1 into Q minus 1. So this is congruent to 1 modulo PQ. Okay. Just simply Fermat's theorem apply karo. Fermat's theorem states that suppose P is a prime, and just see that what is Fermat's theorem. Let A be an integer. P is prime and P does not divide A, then A to the power P minus 1. So this is congruent to 1 modulo P. Okay. So by Fermat's theorem, what we can write? P is prime. So by Fermat's theorem, P is prime. So A to the power P minus 1. So this is congruent to 1 modulo P. Q is also prime. So A to the power Q minus 1. So this is congruent to 1 modulo Q, right? So this implies A to the power P minus 1. The power and Q minus 1 porchi. So into Q minus 1. So this is congruent to 1 to the power Q minus 1. That means 1 modulo P. ঠিক আছে এবার এটা রিলেশনে বোথ সাইড পাওয়ার কি করছি p - 1 so this implies a to the power p minus 1 into q minus 1 so this is congruent to 1 modulo q. Now just apply this result. A is congruent to b modulo m and A is congruent to b modulo n. M and n are relatively prime. If M and n are relatively prime, then A is congruent to b modulo mn. M আর n কি হয় মাল্টিপ্লাই হয়ে যাবে কন্ডিশনটা কি M and n কি হতে হবে রিলেটিভলি প্রাইম হতে হবে so here just see P and Q are distinct prime that means GCD of P and Q is 1 so this is congruent to 1 modulo PQ হয়ে যাবে ঠিক আছে so since P and Q are distinct primes since P and Q are distinct primes so A to the power P minus 1 into Q minus 1 so this is congruent to 1 modulo P and Q multiplication that is 1 modulo PQ. So we prove this. Okay, so proved. ঠিক আছে so if P and Q are distinct primes A be an integer not divisible by both P and Q then A to the power P minus 1 into Q minus 1 so this is congruent to 1 modulo PQ. Okay ঠিক আছে so let us consider next example. So note this problem. It is a very very important example. If P and Q are distinct primes, P and Q are distinct primes that means GCD of P and Q is 1. It should be noted that P and Q are distinct primes that means P and Q are relatively prime. That means GCD of PQ is 1. Relatively prime that is also called co-prime. Okay. So note this problem. If P and Q are distinct primes then prove that P to the power Q minus 1 plus Q to the power P to the power Q minus 1 P to the power please correction this P to the power Q minus 1 P to the power Q minus 1 plus q to the power p minus 1. Okay, please correction this, p to the power q minus 1. Okay, p to the power q minus 1 plus q to the power p minus 1. So this is congruent to 1 modulo p. Okay, ঠিক আছে, p to the power q minus 1 plus q to the power p minus 1. So this is congruent to 1 modulo p. P to the power q minus 1 plus q to the power p minus 1. So this is congruent to 1 modulo p. We have to prove this. ঠিক আছে? So since p and q are distinct primes, so GCD of p and q is 1. So answer, since p and q are distinct, since p and q are distinct primes, so GCD of p and q is 1. Now apply Fermat's theorem. Fermat's theorem states that a to the power p minus 1, so this is congruent to 1 modulo p. ঠিক আছে, p is prime. So by Fermat's theorem, just you consider, suppose a is equal to q is prime. Okay, so what we can write, but তুমি first আমি কি করতে পারি দেখো, this is the Fermat's theorem. So what we can write, q to the power p minus 1, so this is congruent to 1 modulo p. এটা লিখতে পারি আমরা q to the power p minus 1, so this is congruent to 1 modulo p. Again we can write p to the power q minus 1, so this is congruent to 1 modulo q. লিখতে পারি কিনা দেখো, p and q, what is given, p and q are distinct primes. P is a prime number, q is a prime number, p is a prime number, q is a prime number, right? So a to the power p minus 1, so p is prime, a to the power p minus 1, so this is congruent to 1 modulo p. So what we can write, q to the power p minus 1 is congruent to 1 modulo p. লিখতে পারি আমরা। Again what we can write, p to the power q যদি prime হয়, q is a prime, that it is given, so p to the power q minus 1, so this is congruent to 1 modulo q. ঠিক আছে, p to the power q, মানে q is a prime number, p to the power q minus 1, so this is congruent to 1 modulo q. A to the power p minus 1, so this is congruent to 1 modulo p. So p to the power q minus 1, so this is congruent to 1 modulo q. Okay, q to the power p minus 1, so this is congruent to 1 modulo p. লিখতে পারি a to the power p minus 1, so this is congruent to 1 modulo p. পাওয়ার যেটা থাকবে a to the power p minus 1 is congruent to 1 modulo p. তাহলে একবার তুমি a is equal to q consider করছি, so what we get, q to the power p minus 1, so this is congruent to 1 modulo p. আবার a is equal to তুমি q consider করো, so p consider করো, so p to the power q minus 1 is congruent to 1 modulo p. Just Fermat's theorem. Okay, so by Fermat's theorem we get p to the power q minus 1, p to the power q minus 1, so this is congruent to 1 modulo q. হবে, suppose this is equation 1, suppose this is equation 1, right? A to the power p minus 1, so this is congruent to 1 modulo p. P to the power q, মানে q is prime number, p to the power q minus 1, so this is congruent to 1 modulo q. Now just see, q obviously divides q, right? q নিশ্চয়ই q কে ডিভাইড করে, একদম q কে ডিভাইড করবে, q স্কয়ার কে ডিভাইড করবে, q কে অবশ্যই ডিভাইড করবে। সো আমরা কি লিখতে পারি, q divides, what we can write, q divides p minus 1, that means p minus 1 টাইম যদি q মাল্টিপ্লিকেশন থাকে, q into q dot p p minus 1 times, so obviously divide. দেখো q q স্কয়ার, q q কে ডিভাইড করে, q q স্কয়ার কে ডিভাইড করে, q q কিউব কে ডিভাইড করবে, so what you can get, q divides q to the power p minus 1, right? So also what we can write, q divides q to the power q minus 1, ঠিক আছে, ওকে। So q divides q to the power q to the power q divides q to the power q to the power p minus 1 লিখতে পারি আমরা, ঠিক আছে, ওকে, ঠিক আছে, রাইট। সো নাও q কাকে ডিভাইড করছে, q to the power p minus 1, so this implies q to the power p minus 1, so this implies q to the power p minus 1, so this is congruent to 0 modulo q, very simple। দেখো q কাকে ডিভাইড করছে, q to the power p minus 1 কে, ঠিক আছে, তাহলে আমরা কি লিখতে পারি, q to the power p minus 1, so this is congruent to 0 modulo q, ডিভিজিবল মানে রিমাইন্ডার কি হবে 0, so q to the power, দেখো just see, suppose a is congruent to b modulo m, what does it mean, that means m divides a minus b, m কাকে ডিভাইড করবে, a minus b কে, p q to the power p minus 1 minus 0 is divisible by q, দেখো a is congruent to b modulo m, that is a minus b is divisible by m, q to the power p minus 1 minus 0, so this is divisible by q, ঠিক আছে, ওকে, very simple, ঠিক আছে। So what we can write, q divides q to the power p minus 1, that means q to the power p minus 1 is congruent to 0 modulo q, okay। Suppose this is equation 2, suppose this is equation 2, now adding this, so what we get, যদি add করো, so what you get, p to the power q minus 1 plus q to the power p minus 1, so this is congruent to 1 plus 0, that is 1 modulo q, so adding 1 and 2, adding 1 and 2, we get, so p to the power q minus 1 plus q to the power p minus 1, so this is congruent to 1 plus 0, that means 1 modulo q, ঠিক আছে, ওকে। Again by Fermat's theorem, what you can write, q to the power p minus 1 is congruent to 1 modulo p, q to the power p minus 1, so this is congruent to 1 modulo p, right? Again by Fermat's theorem, a to the power p minus 1 is congruent to 1 modulo p, right? So q to the power, p is integer, p is a prime number, q to the power p minus 1, so this is congruent to 1 modulo p, right? q to the power p minus 1, so this is congruent to 1 modulo p. Now same process, okay, also দেখো p নিশ্চয়ই p কে ডিভাইড করবে, p নিশ্চয়ই p স্কয়ার কে ডিভাইড করবে, p divides p divides p স্কয়ার, p divides p কিউব, রাইট? সো p divides p to the power q minus 1, it is obvious, p divides p divides p square, p divides p cube, p divides p to the power q minus 1, so this implies p to the power q minus 1, so this is congruent to 0 modulo p, right? P divides p to the power q minus 1, that means p to the power q minus 1 is congruent to 0 modulo P. Clear? Just see, this minus this is divisible by P. A is congruent to B modulo M. That means A minus B is divisible by M. So P to the power Q minus 1 minus 0. So this is divisible by P. That means P divides P to the power Q minus 1. That means P to the power Q minus 1 is divisible by P to the power Q minus 1 is divisible by P. That means P to the power Q minus 1 is congruent to 0 modulo P. ঠিক আছে? ওকে, এবার এই দুটো রিলেশন অ্যাড করো। সাপোজ দিস ইজ ইকুয়েশন 3 and this is equation 4. Okay, suppose this is 3 and this is 4. So adding 3 and 4. So adding 3 and 4, we get Q to the power P minus 1 plus P to the power Q minus 1. So this is congruent to 1 plus 0. That means 1 modulo P. ঠিক আছে? Okay, right? Now just see this. Suppose this P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo Q. Again P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo P. Just apply this. A is congruent to B modulo M and A is congruent to B modulo N. So A is congruent to B modulo কি হবে? Mn হবে। Conditionটা কি হতে হবে? Satisfied provided GCD of M and N is 1. So here we see that P and Q are relatively prime. Therefore A is congruent to B modulo M. A is congruent to B modulo N. M and N are relatively prime. So here P and Q are relatively prime. Take. So what we can write? So we can write P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo PQ. Okay. ঠিক আছে? Clear? So since P and Q are distinct prime, that means GCD of P and Q is 1, right? Since P and Q are distinct primes. Okay, so P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo কি হবে? Modulo PQ হবে 1 modulo PQ. Just you consider this is A. A is congruent to B modulo M. A is congruent to B modulo N. M and N are relatively prime. Then A is congruent to B modulo Mn. ঠিক আছে? Okay. So we proved that. So please correction this A to the 1 modulo PQ. Okay, 1 modulo PQ. So we proved that P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo PQ. Okay, so proved. It is very, very important example. P to the power Q minus 1 plus Q to the power P minus 1. So this is congruent to 1 modulo PQ. Okay. So আজকে Fermat's theorem এর টোটাল 7 প্রবলেম ডিসকাস করলাম। ওকে, সো অল প্রবলেমস আর ভেরি ভেরি ইম্পর্টেন্ট। প্রতিটা প্রবলেম খুব ভালো করে সলভ করবে। ওকে, সো আই থিঙ্ক অল পয়েন্টস আর ক্লিয়ার। সো থ্যাংক ইউ সো মাচ। বাই।